And that's great. You've actually kind of done the job of my first slide, really, which was to explain who I work for and what we're all about. But as you say, I work for PLOS. We're a non-profit open access publisher, and we are really, mission-driven around open science. As you explained, it's about opening publications, but everything else around that research process to anyone who has access to the internet. So I specialise looking at open data and open code, but we also think about open methods and the transparency and kind of accountability of research. We're making sure that the ethics that went into that research is transparent and that people are adhering to various guidelines and standards within their communities. And we do this for the life sciences and medical sciences, and we launched some new climate-based journals. So we publish 12 journals, about 20,000 research articles a year, and we try and make sure that they are as open and as rigorous as possible. And as I say, my job's really around the open kind of data and code aspects of that. Now, what drew me to come here today was the call for papers that I saw. And there was one particular line in it, and this is a kind of snapshot of that. And it was about the value that we got from opening up medical research data around the COVID-19 pandemic. And it's true, the genomes were sequenced, they were shared quite widely, and they were done quickly. Organisations like WHO, big funders like the Wellcome Trust across the globe, institutions all had policies and committed to making data and research into COVID as open as possible, as quickly as possible. And that was great. And we saw, a big rise in preprints, so research articles that hadn't gone through a review process being shared so that information could get out there more quickly. And that's great on the face of it. But actually, when you delve down a bit deeper, you start finding actually it's not quite as rosy as perhaps the statement makes it look. So there is a place called the Research and Research Institute, RORI, and they did a study looking at research into COVID and the way that it was disseminated. And they looked at, the speed of kind of the articles coming out, the data that was shared, all the kind of those processes around it, how quickly was that shared. And when they looked at data, they looked at a couple of different, I think it's about 5 or 6 different studies that kind of summarised the results. And the best case study found that I think it's about 48% of the data was shared. I'm going to say shared. In the kind of best case scenario, it was on the internet somewhere. Other studies were finding more like 28%, 23%, 15%. And then one study looked at actually how much of the data was reusable. It goes down to something like 2%. So actually, even when there is a big push for data, we're not seeing the results in open data. And so they summarise it really nicely in the report, saying, even in the time of crisis, in a global crisis, there's still a great deal that we need to do to create an environment where research data becomes part of business as usual, that open data. And so it's not just the COVID pandemic that, makes data sharing important, it's the utility of data across the spectrum. And there are lots of policies around data sharing. And we say data sharing because open data puts a few people off, because they can't share their data for legitimate reasons. So we tend to say data sharing. And, there are funders, there are governments, there are institutions, all have policies around open data. And we don't really have a good sense of how much of that data is open. And so why do we want to measure this open data? Why should we even try and quantify that? Well, first of all, we want to quantify the return on investment that funders are putting in. Billions and billions of pounds go into research every year. It would be nice to know what the outputs of that is, other than 6 pages describing someone's results and conclusions. We want to see the impact of those policies. So actually they're spending a lot of time and energy writing policies, finding the guidance. It would be nice to know if that's actually having any effect. And once we have that baseline and understand what data is being shared in academia, we can then start thinking about strategies to increase that data sharing, right? How do we do that in general? How do we do that to support different disciplines? Because they'll be working with different data types, with collecting data in different forms from different subjects, in different areas as well. So how can we support those different groups to suit their needs? And then also, if we have an idea of what data is being shared, we can actually start examining that potential for data reuse, or potentially not. So, in academia, we work a lot on the principle that we should just share all data. And that's partly because of reproducibility concerns, that if you share that data, then we can check the authenticity of those results. But actually, we're really just starting to have conversations about whether it's really worth sharing all of that data from a reuse perspective. Erin made that great point just at the very end of that last session about the cost of data and how much data is being produced. So we also need to start thinking around conversations about the lifetime kind of journey of that data and whether it's really important to be sharing all of that data. But for now, we're just kind of at that starting point, like, let's just try and share all the stuff we can. So that's a later conversation. It could be a whole talk in itself if you're lacking another speaker.
You've got another slot.
Thank you. And, there's been research, and it's asked these kind of funders, these institutions, do you measure how people comply with your research data sharing policies? And these are some of the quotes we got from a study that we did. And they say, well, it's really labor intensive, it's a manual process. And one of the biggest reasons why they aren't measuring those is they lack kind of tools and infrastructure to really understand what data is being produced and if it's being shared and where it's being shared. So this is kind of really what's behind our project, trying to understand the open data landscape in terms of what's being shared. And then once we can understand how much data is being shared, we can start looking at characteristics, we can start looking at reuse more, and build a better understanding of what open data actually looks like in science and academia. So what would success look like if we had a perfect open data sharing landscape in academia? Well, data is shared as much as possible with those caveats that, obviously if there are ethical, legal reasons why it can't be shared, it's not shared. And also with that caveat that maybe we want to start thinking about why we're sharing that data and whether everything really does need to be shared and in what forms. And also that data is fair. So you may have come across the FAIR principles, that data is findable and accessible, it's interoperable and reusable. Now these first two, findable and accessible, are fairly easy to measure because you've just got to find the data and you've got to be able to get it. The interoperability and reusability questions are actually really hard to measure in academia. And the work we've done at the moment, we've only been kind of started about 6 months ago, we've really concentrated on the findable and accessible stuff, and I'll be talking about that more. But it's just to acknowledge that actually interoperability and reusability are huge issues with academic data. With all data, I suppose, especially academic data. And that I think that's almost like a second phase of thinking about open data in academia, that once we've got this baseline about actually what is out there, we can start thinking about the reusability of it and the interoperability, and actually how do we address that as communities working with academics. Or how do the community decide themselves, which is also another important point. So how do we measure open data in academia? Well, we started off with a framework, and we built this framework to really kind of guide our work, and we thought about the principles that we want it to be built off. So we thought about things like that it is plugged into like community initiatives that already exist. So we're not starting from scratch when things already exist. We're building into existing efforts. So, for example, there is the UNESCO framework on monitoring open science. They are thinking about this. We've built our framework so it very much gels with what they're doing. And we're building off open source efforts that are out there already. So we're not, we're trying to reuse, repurpose, and plug into stuff. We selected a partner to work with, and we work with DataSeer. They specialize in kind of natural language processing and AI-based analysis of research article text to look at that kind of open science around academia. So we work with them very closely, and they're looking at our framework, deciding what our kind of criteria for measuring open science. And again, we're measuring things like open data, open code, whether things like preprints have been shared. We're looking at open methods as well. We've added context. So DataSeer have taken some open source efforts around quantifying and measuring open science, and they're kind of adding to it. So whilst previous efforts have looked at whether data is shared or not related to a piece of research, what we've done is got them to look at whether data is generated to start with, and then whether it's shared. And so most research does generate data, and so you think, why bother? But when it comes to things like code, it's really important to know if code's being generated by that research when you're thinking about whether it's been shared. And so, for example, we've found about 50% of the articles that we publish generate code. So there, when we look at the code sharing rates, we can put that into context. We also add context by just using the metadata that comes with research articles, so looking at countries of origin of the authors, disciplines, that type of thing. And then we analyze open content. So all the content that we publish at PLOS is open. We've analysed about 61,000 of our own articles from 2019 to the middle of last year. And we've also got what we call a comparator set. So we've taken about 6,000 articles from PubMed Central, so it's an open source of literature. It's topic matched, the kind of things we do. So again, this is going to be biased to the life and health sciences. But that's all openly available, and we've analysed that. So we can look at what we do as a publisher, but we can also look more broadly at the scholarly landscape and think about how open data is across research in general. So that's what we've done. As I say, we've only been doing this kind of 6 months, so it's a bit of a work in progress, and this is a kind of version 1 of the data set, and we are building and adding and refining that going through this year. So how much data is open? Well, if you look at comparators, so the scholarly literature at large, we find around 50 to 60% trending upwards across the years, which is great, right? More data is becoming open, hooray. If you look at the PLOS data on top of that, so this is from our journal articles, you can see that that line is higher, 70 to 75%. And so that tells us already that publishers can influence data sharing strategies. We mandate data sharing. You cannot publish with us unless you share your data. Whereas the comparators, some of them might mandate data sharing and others might not. So, you can already see that things like policies have an effect on what academics do. And you might be thinking, I thought you just said you had a mandated data policy and you're only at 70%. What's going on there, Lauren? Well, good question. That kind of 30% chunk, there are various reasons for that. There will be research that can't share its data for ethical and legal reasons, and that's perfectly acceptable and legitimate. There will be research articles that share their data, but actually their metadata is really bad. And so when it comes to the analysis from my data, it's just not detected. So that's telling us that actually we may be sharing data, but we're not talking about it in a way that facilitates the discovery of that data so well. So we need to think about, as publishers, and as also as researchers sharing their data in general, like, how best do we describe where our data is, and how can we do that in a consistent way across different publishing platforms that will really enable kind of data discovery into the future? And of course, there will be an element of non-compliance. We're only human, things slip through the net as well. But really, it's those kind of ethical reasons of that bad metadata that makes up the majority of that kind of portion that's missing. So this is a fairly rosy picture, right? I just said COVID data wasn't shared very much. And I'm giving kind of nice high numbers here. But that's being really generous again, right? So this is just data that is shared somewhere. When you think about making data open and findable and accessible, you get a bit of a different picture. So if you look at data that's shared in a repository, so somewhere designed to host that data for long term, to aid discoverability, that comes with open licensing and all of that jazz, the numbers really drop by quite a considerable amount. So we're getting to around 10% in the scholarly literature of data that's open. Again, at PLOS we do a bit better because we mandate data sharing. Sorry, I should turn my phone off. And it's only really this kind of bottom chunk that is going to be findable and accessible. We don't really know if it's interoperable or reusable. Probably not a great deal is, because that is a big area we know we need to work on. And the rest of this stuff, it's either like data in supplementary information, so that's like an appendix on a journal article, so it would be buried in a PDF somewhere. And often, you have tabular data just saved in a Word document or that kind of thing, so it's, rubbish data, or data presented in a bad way, I should say. Or you do have data on websites, personal websites, for example. And so there's a lot of data out there. It's just not necessarily kind of well-presented data in a way that makes it really valuable for that kind of societal impact for reuse for other people taking on. We can also look at the data across the globe. And when we think about open data and kind of classifying different regions, we tend to think about the barriers or accelerants to open data. So things like, do countries have policies around open science? Do they have funding to support it, infrastructure to support it? And what are the language barriers as well? Because a lot of open science conversations happen in English. And so, there's an acknowledgement that that's a problem and it's starting to change. But again, that will take time. And I'm not sure how well the colours come out on this map, but the UK, US, Canada are really dominating the conversations around open data, and that's reflected in the percentage of data that again is in a repository. Whereas in different parts of the world, we see that they really need, more support, more funding, more infrastructure that really works with their needs. So at PLOS, we partner with different organisations like TCC Africa to really try and understand what it is that we can do to support and encourage open data in different areas and to support our authors who come from those regions, and actually what initiatives can we do to help them. And that's a big part of my job, is really trying to support researchers with those data sharing requirements. And then we can also look at open data by discipline as well, and that can really, again, give us an idea about which disciplines perhaps are well supported versus which ones might need a bit more education or advocacy, or have really difficult data types that makes data sharing difficult. So computer and information sciences are doing really well. About half of it is in a repository. That's great. If you look at it being shared in general, they go up to kind of 90%, but a lot of that might be on personal websites. They should quite like it in that discipline, and it falls down. And I think medicine related research being quite low is probably understandable because of the ethical restrictions around sensitive personal data. But if you think about the societal impacts that data can have and the utility of data in other areas, thinking about environmental and earth sciences and climate change and the big push to think about our impact on the world, you'd be wanting to see more of that data out there and reusable by others. So they're just some insights into some of the open data in academic research and what we can learn from really just trying to understand where open data is at. Our data set is, of course, open. And if anyone wants to access it, it's all there to use. As I say, it's a work in progress. We're aiming to release updates to that data set every quarter, so add more articles that have been analysed, tweak the algorithms, make them more precise, etc. And it should be out at the end of March, fingers crossed. I'm hoping there's some data in my inbox right now. So I will leave it there. Thank you very much, and I'll have time for questions.
Yeah, we've got time.
There's
5 minutes for questions.
Perfect.
Questions, anybody? Questions, thoughts?
Okay.
Oh, quite a few over here. We've got a microphone. Ah, there it is. So there were a couple here on this side of the room, hands high, and then there's two gentlemen here have questions as well. Shall we take those first? They were the first hands up. I'm trying to be fair. Sorry.
Very good.
Is there any talk about extracting data from papers, scientific papers, for example, or a way of, when scientific papers are published, that the sort of metadata includes the actual stats and facts and evidence are inside the papers themselves in a standardized way?
Yeah, so there are actually a couple of initiatives around that. So Data Work on one of them, there's another called SciScore, that take the full text of an article, will process it and come out saying, okay, you've produced data on these things, or you've referenced these things, you need to cite that data or share that data, or these are your materials that you've talked about, you need to cite those properly. So they do exist. At the moment, they exist generally for specific disciplines. So it's kind of that scalability of getting it ready for across disciplines and across different use cases. So it's something publishers work with different organisations on, trying to bring that into the process.
Hello.
Hi.
Scientific literature seems to have a quite uniquely powerful thing, which is the ability to see which papers are cited, and you can kind of tell which papers are the big ones.
Yeah.
Is there a similar thing being done with open data in science? And if not, why not?
So data citations is like a whole other world of problems in academia. There's a big drive to put data in repositories because then they get DOIs and they're persistent identifiers, and you can cite those and we can track them in terms of citations. What we find is that actually people will cite the paper instead of the data, and that's a problem. So there's a whole education piece that's going on around citing data sets instead of papers. And there are initiatives, so one of them is called Make Data Count, that's really looking at this citation kind of argument and trying to do the advocacy and do that kind of data linking as well, so that we can see those kind of citation maps and really start giving data the credit that it's due. So we're working on it.
Okay, so there's one other question over there, I think. And then there's a gentleman here and a gentleman here, and then I think we'll have to wrap up because we're probably going to finish over time, but we're going into a break. Oh, it has. Okay, so only one more question after that one over there, please.
Hi. So I've been working in like the decentralized science movement for like a year and a half. I don't know if you've heard of it. But one of the things that was really interesting was a paper came out in 2020 about like incentivizing peer review. I was wondering if PLOS is doing that. And then also at one point on the citing data, there's an interesting project called DeSci Labs, which are doing DeSci nodes, which are sort of a way to sort of cite different parts of the paper.
Yeah, I mean, there's lots of really interesting initiatives trying to break up that article and the data into different parts to make it citable. So, yeah.
Yeah.
With the incentivized peer review, it's a really interesting question. So for those of you not in academia, it's peer review happens when academics review someone else's paper and they do it for free and they get asked all the time to do it. So there's a lot of free labor in the academic system. There are different arguments of how you can incentivize peer review. Do you pay people? Do you give them a free publication? And no one's really found a perfect solution yet, because they're worried that if you pay people, then they do a quick job, or they don't do a very good job. And so there are, I think, different arguments to be made. We haven't tried any incentivized peer review in terms of like rewarding the reviewer. We do publish open peer reviews, so we're encouraging kind of transparent reviewing practices instead. But review of data itself is actually also a really interesting question, because researchers often review the article. If they're particularly diligent, they might look at the data. They might kind of rerun some of the stuff in the data, but they don't routinely do that. So there's also an interesting question of like, how do we review that data, and whose responsibility should it be? Is it the reviewers who are already doing the free review of the manuscript? Could we get someone else? Should the journal do it? Journals are already doing a lot of stats checks as part of their review. So there is a little bit of kind of quality control there. But these are all big issues in academia that no one's quite worked out the right answer for yet.
So one final question over here.
I'll try and keep it short.
No, don't worry, it's fine. I think this is the most questions we've had. Well done.
So I enjoyed the talk, thank you. Just sort of looking, is there like some more industry-wide effort in the sort of scientific community, among journals and so on, to look at maybe a more standardized approach towards what you guys have been doing here? Because in the end, I mean, I know IEEE is around and sort of other publishers which are maybe more known in my field, right? So do you work together around other open access journals, publications, to build really a framework and a bit more standards towards metadata and also standards in sort of like then publishing scientific data and so on? Sorry, I know it could be a very long question to answer, but
I mean, there are we work with different publishers, in the landscape on different aspects. So stuff like the initiative I was showing the data from, we're kind of the first publisher to do it, and we're encouraging people to do it more, and we're sharing our results, and we're actively talking to publishers saying, come on, why don't you do your stuff too? On the other side of like data sharing, there is a big organisation called the Research Data Alliance, and there are working groups there, it's got a really long name, it's like the Data Policy Standardisation Group or something, that are working to get that kind of metadata around describing where data is standardised. And so they're working with publishers, they're working with funders, they're working with the research community to really try and push that kind of standardisation along. And that happens with code as well and other aspects of publishing and data.
Thank you. Okay, I think we should let everybody go and get a cup of coffee now. I'm sure you're all dying to have a drink. So I'd like to thank Dr. Lauren Cadwallader for her amazing talk. Thank you, Lauren.